Then you can tell me what everything stands for. Okay, we got the F, we got the M, and we got the A. Okay.
Okay, yes.
Okay, so what does the F stand for?
Force.
Force. Okay, let me just put it a bit
The
smaller.
gravitational force, yes.
So you're saying it's gravity. The force is gravity.
No, it's just force. It's force.
Force, okay. Okay, what? And then we got it's a mass?
Yes.
And then we got an acceleration.
Yes.
Okay, now I want to ask you. I'm just going to say acceleration. So what is acceleration? Is that gravity?
Yes, the acceleration is gravity.
Okay, so acceleration is gravity, okay?
Little a, yes.
Great.
Gravity.
Okay, now, what is the mass? Mass is just the mass.
Just mass. Yeah.
Okay, what's
How big an object is.
So what's the F now? What's the force then? If gravity's the acceleration, what's the force?
It's m times a. When you multiply m times a, you get the force.
No, you require a force for a mass to accelerate.
No, that's not.
So you don't require a force for mass to accelerate.
It's the other way around. You require a mass and an acceleration for the force.
Exactly. So without the force, you can't have a mass accelerating.
Without the force, you wouldn't have the mass or the acceleration.
You can't have a mass without force. Why?
You can't really have a mass without force.
So a block of steel has mass, correct?
Yes,
Is it accelerating?
It causes the acceleration.
So that means it requires a force for that mass to cause an acceleration.
If anything, if you erased everything from the universe and just placed a steel block, you would that would be a mass.
Yeah, I agree. There's mass, and we observe an acceleration. Therefore, you require a force. Now, if you're claiming acceleration is gravity, what causes the force? What is the force that causes gravity?
Well, I don't think that anyone knows that yet.
So
like I don't think what's the explanation as to why things get drawn together. We don't know. I don't think they know that yet.
Things don't get drawn together. Would you agree then, because you say acceleration is gravity, if I accelerate with a car, is that caused by gravity? Is that gravity?
Well, it has a different one. That's the engine.
Great. So we would know the force comes from the engine.
Yes, the engine causes the force.
But the acceleration is not gravity there.
You'd still have the gravity. It's just that the force created by the engine would overcome gravity in this case.
No, remember the force is causing the car to accelerate. So we know the force is caused by the engine pushing the mass along, which accelerates it. So therefore it's not gravity. Gravity has nothing to do with the vector. Now, if we take a stone and throw it out of an airplane, it's accelerating towards the ground.
Yes.
Okay, and you would say that acceleration is gravity?
Yes.
Okay.
Well, yes.
So what is the force that gave that acceleration?
Well, it's the Earth, I suppose.
So the Earth caused gravity?
Technically, you could say that, yeah. Any bit of mass causes gravity to appear.
So then we would say mass equals mass times acceleration.
No. All you need for gravity is mass.
Oh, okay.
So
A mass on its
that.
own,
Remember that.
a mass on its own, causes acceleration. Is that what you're saying? It doesn't require force then.
No, because you'd need the acceleration for the force. So, force.
Remember, you said the acceleration is gravity.
Yes.
So we're observing acceleration. So you're saying we're observing gravity.
Yeah.
So
That's fine.
great. So what is the cause for that acceleration?
Cause for the acceleration. Are you saying like what causes acceleration?
If I drop that stone out of an airplane and I observe it accelerating, you're saying that's gravity. What causes that observation? What causes that rock to accelerate?
The other mass.
What other mass?
The Earth, right?
The Earth can't do anything. The Earth is not a force. The Earth is just another mass.
The Earth is mass.
But you're saying it's a force. So you saying mass and force is the same thing?
No. Mass and if you have a mass, you have basically an acceleration that you can't observe until you add another mass.
I can take a scale and I can put a mass on there and I can measure it.
Yeah, that's from gravity.
No, it's not. You do know it measures pressure that the mass is having on the load cell.
The scale, if you get on a scale, you have mass, the Earth has mass, and you're drawn downward to the center of that mass. Therefore, the weight on the scale would reflect how fast or you're being drawn down by the Earth's gravity.
Then why is it if I stick that same scale in water, it won't pick up my mass?
Well, because there's pressure all around it.
So pressure is the cause then. Yeah, so buoyancy. So you would agree it's the pressure that gives the reading, not the mass.
No, because there's everything all around it. Everything's pushing on it from all directions in water, so it wouldn't really pick up any weight.
But you understand what you're doing? You're making a claim that mass is attracting mass. You make that claim.
Yes.
So how would you prove that?
Well, with an experiment, I suppose.
Okay, and how would you do this experiment? So you would say it's scientific then?
Yeah, a scientific experiment.
Great.
That follows the scientific method.
Okay, so cool. You understand the scientific method. So would you be able to please give me the hypothesis and experiment for gravity?
Yeah, let's say. Okay, so the first step is observation. I observe something falling. I suppose that would be the observation. Yeah, the observation, the hypothesis can be whatever you want, I think, right? Yeah. The hypothesis is why you think that object is falling.
Yeah.
I think it's because the two masses are drawn together. But of course, the hypothesis can be anything. I can say that...
They have to stop you there, though. You have to give the cause. So if you're saying two masses attract each other, how are you going to manipulate that?
I guess I get two masses and see if they attract each other or not.
No, you have to manipulate the independent variable. You're saying you're seeing something
Yes.
fall to the ground, accelerating. And you
Uh-huh.
claiming it's the Earth attracting the rock.
Yes.
So how are you going to manipulate the Earth?
I can manipulate the well, if I'm saying mass attracts mass, then I can get two masses and put well, I'd have to isolate lots of variables like the wind or atmospheric conditions. Like I'd probably put the balls and myself out of the equation too, because
How are you going to do? How are you going to
have
take? How are you going to take the mass of Earth out of the equation?
well, the mass of Earth is constantly pulling things down.
But you see, that's the thing. That's the issue here. You're claiming the mass of the Earth is the cause. So that is the thing you have to manipulate to state it's the cause. You're not going and manipulating the Earth. So therefore, it's not scientific.
I'm not saying the Earth. I'm just saying mass attracts mass. It doesn't matter what the masses are.
No, you observed a stone falling, falling out of a plane, accelerating towards the ground. You claim it's the Earth attracting that stone because mass attracts mass. That's what you claim. So the cause would be mass then. The cause would be great. So the cause would be Earth.
In this scenario, yes.
Okay. Now, how would you go and manipulate your presumed cause, which would be Earth?
Well, if my hypothesis is just mass attracts mass,
but you don't observe just mass attracting mass in reality. You observed a rock falling to the ground. You don't observe mass attracting mass.
But your hypothesis can be whatever you want it to be.
No, your hypothesis has to be what you observed in reality. Just like you said, observed natural phenomena. The natural phenomena was rock accelerating to the ground.
Can be whatever you want it to be.
Right, so
that's fine.
We observed now in nature, we observed a rock falling to the ground.
Yes.
So now your hypothesis has to be built on why I see that rock falling to the ground.
Yeah, why does the rock fall?
Yeah, and you claim it's because the mass of the Earth is attracting that rock. So therefore your cause would be the mass of the Earth. So you would have to manipulate the mass of the Earth.
I just have to... Oh no, I lost my... all I saw was the rock falling to the ground. So, from that, I probably wouldn't be able to say what made it fall.
Yeah, exactly.
What
you just observed it fall. We just observed it accelerating. So therefore we know there is a force.
Yeah.
There's definitely a force because we observe an acceleration. So you're saying that acceleration is gravity. So so if you say gravity is what we observe, you just renamed acceleration to gravity.
Yeah. You can call it what you want, I guess. Before we gave it a name.
So that's what I've got to ask. So what causes that acceleration? Is it gravity causing that acceleration?
Yes.
So gravity causes gravity.
Gravity...
So acceleration's not gravity then? So acceleration's just acceleration?
Acceleration is caused by a change in velocity. There you go.
Great, so we can say it's not gravity. I can take that out then. We can say acceleration is not gravity then. Acceleration is just acceleration. That's the magnitude.
No, the acceleration is caused by a change in velocity, but
And
velocity
as a vector, so it has a magnitude.
is a vector, yes.
Great.
That includes both speed and direction.
Nice. Okay, so we're going to say that vector is down.
Yes, the vector is down.
Okay, great. And we know it's a rock, so I'm just going to draw a rock there because that's our...
Therefore, any change in speed or direction of any object's motion does result in acceleration.
Yeah, but look what I'm saying. So we got the aeroplane above here. Excuse the aeroplane, it's just a quick little... Okay.
This change can occur due to the application of a force.
No, but you would agree, according to F equals ma, we see an acceleration of the rock, that would be the mass, that would be the acceleration. We actually can see this. You would know you require a force for this mass to accelerate. Now,
yes.
Okay, so once we see the accelerating rock, are you claiming the cause for that acceleration is gravity?
It's... Yeah.
So then force... So then we can say force is gravity then.
In a very basic term, I suppose you could say gravity.
But you see how that contradicts. But you see how that contradicts gravity, though, because gravity is not a force. So you can't claim the force.
Yeah, gravity is not a force.
Yeah, so we can't claim the force to be gravity. Then that's the issue.
Yeah, gravity. But as it turned out, that is not actually correct for every situation. It's correct for some situations. Saying gravity is a force is correct for basic situations. But if you want to get more advanced with the details, then you'd see that actually gravity is not actually a force, after all.
So
it causes a force.
Okay, so we have to take gravity out here then, because then gravity is not the force. So the force...
No,
there's a force. Okay, okay, so that's what we see now. So where does gravity fit into the situation here?
It fits into the A.
No, you said that, no. You said that's an acceleration downwards, got a magnitude.
Yes.
So if gravity, so gravity causes gravity again.
No, gravity due. It's acceleration due to gravity.
But that's what I'm saying. So you're claiming gravity causes the force, which causes the acceleration, which is gravity.
It's like if I go one. It's like if I go 1 equals 1. You know.
Mm-hmm. Yeah, 1 equals 1.
Yeah.
Exactly, but...
You...
So you're saying gravity equals gravity?
Or A equals B or something like that. You know, the F in this case would come after. So it would be M times A equals F.
Great, okay, let's do that as well.
In this one, it's just, for simplicity, it's F equals MA.
Okay, so
because that's
great. So the mass times acceleration is equal to having a force.
You can't have yes.
Great. So
it's a force.
So it's the same thing. You require the force for that mass to accelerate.
Yeah.
Great. So what would be the force here?
The force, it would be created by both mass and acceleration.
So you're saying mass and acceleration is gravity?
No, mass and acceleration causes a force. But the force is not gravity.
Sorry. The force causes a mass to accelerate, not a mass and acceleration causes a force. The mass cannot accelerate without having a force.
But look at the bottom one. Ma equals F, right?
Ma equals F means we're observing a mass accelerating, which requires it to have a force. That's what it means. It's still the same thing.
Well, it's equal to a force. You know?
Which means we do have a force. And gravity is not a force, so you can't claim gravity to be the cause for the acceleration.
Why not?
Because you require a force, and since gravity is not a force, you cannot claim it to be the the cause for the acceleration. It has to be something else then.
You want what causes the force?
You claiming the force is due to gravity. Correct.
Yeah, the force.
So then I'm going to ask you the same thing I asked McToon last night. What is gravity?
When a force is exerted on an object with a mass, it results in acceleration of that object.
I asked what is gravity?
I guess acceleration, right?
No, but then you claim, but then it's again the same, going back to then gravity causes gravity.
So I guess it would be different in regards to, pushing or pulling an object, because the acceleration in that instance wouldn't be caused by gravity. It would be caused by you pushing the object, making it accelerate forward.
So then you would agree then it's not gravity pulling the rock down to the ground.
It's a force, right?
No, gravity is not a force, so it can't give a push or a pull.
No, I mean, it's a force that pulls, right?
Yeah, a force can push or pull.
Yes. It's a push or pull, yeah.
Yeah. So, like I was saying, so when we see an acceleration and can't be gravity because gravity can't push or pull, how can you claim it to be the cause for an acceleration?
So, wait, what's your question?
You're claiming that gravity is not a force, yet you're claiming gravity is the acceleration due to a force. So you're claiming gravity causes gravity and it's not a force at the same time.
So, no, but what? So, can you phrase that in a question form?
Yeah, how can you claim gravity to be the cause for gravity?
But that's not really me.
So then you would agree with me, based on simple logic and thinking about this, looking at it, breaking the F equals ma down. Gravity is just a belief. There is no gravity, where it's an illusion that we believe to exist. Because it contradicts physics.
I think there's a mix-up in your question of you saying gravity be the cause of gravity.
But you said acceleration is gravity, and you said gravity causes the force which causes the acceleration. So gravity causes gravity.
No, gravity itself is not the cause of gravity. It is the force that results from the mass of an object,
So if I stick two marbles next to each other, will they attract each other?
Yes.
Two marbles, will they just attract each other?
Well, if there's nothing else if there's nothing else in the world, like, let's say that
You see, that's the
we
thing.
start over from zero.
But you see,
Everything's gone now. No Earth, no Sun, no anything.
but you see, that's the
And
problem.
we just have two marbles next to each other. Then yes, they would attract each other.
So that's not something we can do in reality. Then it's all just mathematically based. Narnia.